these are some of my favorite math stories.
In this episode, Mathematics is 6 degrees. We'll look at the small world phenomenon, also known as 6 degrees of separation. We start, though, with a collection of oddities from very different origins. In 2025, Division III Roanoke College had its first full season of college football since 1942. One way of saying that it was successful is to show how the team was better than the number 2 team in the nation, Division I. Don't believe it? Well, check out the following list of results from the 2025 season. Roanoke College beat Greensboro, which beat North Carolina Wesleyan, which beat, and so on. Get down to the bottom, got Clemson beating Louisville, and Louisville beating Miami. Miami was in the national championship game. My football rating system, see the episode Highly Rated, depends on all teams being connected in this way. In the Kevin Bacon game, you name an actor and try to connect to Kevin Bacon in as few steps as possible using movies. For example, if you choose Robin Williams, you might say that he and Julia Roberts were both in Hook, and Julia Roberts and Kevin Bacon were both in Flatliners. The game, started by some graduate students in a late-night party and promoted by a local radio host named Jon Stewart, is popular in part because it rarely takes more than 3 steps to reach Kevin Bacon, and he is not really the biggest of stars. The mathematician Paul Erdos was famous for being prolific, approximately 1,500 publications, and for his collaborations, co-authoring with about 500 others. A game among mathematicians is to determine their Erdos number. It's 1 if you wrote a paper with Erdos, 2 if you wrote a paper with someone who wrote a paper with Erdos, and so on. If you're curious, my Erdos number is 4, having written a small article with my son who has an Erdos number of 3. 6 degrees of separation became a popular concept with John Gar's 1990 play of the same name. The idea is that you are 6 or fewer acquaintances away from anyone else on the planet. Well, how could I connect to someone on a different continent? Well, knowing Roanoke College students Liz from the Ukraine, Agnes from Palestine, and Soo-Yun from Korea gets me to many parts of the world in one step. So that's a good start. It's fun to think about how you might connect to a famous person or to a random person abroad. Let's start with the origins of 6 degrees of separation. Why 6? Psychologist Stanley Milgram conducted an experiment where letters were sent to randomly chosen people in the Midwest. Given the name, address, occupation, and so on of a target in Boston, they were to mail the letter to him if they knew him, or to record their information and forward it to someone they are on a first-name basis with who might be able to make the connection. About 1/3 of the letters reached the destination, and the median number of mailings was 6. How were people able to connect in so few steps? Well, mathematicians typically tackle problems by abstracting out the most important features of a situation. The 4 games mentioned above are all, at their root, problems in finding the shortest connection between 2 objects. Graph theory models this by looking at problems involving nodes, football teams or people, for example, and edges connecting them, due to the outcome of a game or by being in the same movie, for example. One question that mathematicians work on is finding characteristics of the graph network that result in the small world phenomenon found in our 4 examples. Here's a somewhat vague definition. Small world phenomenon is for any 2 nodes, there exists a small number of edges connecting them. In the book Networks, Crowds, and Markets, we're first presented with an argument for believing 6 degrees of separation. Assume that you know 100 people. That's not hard. And each of them knows 100 people. That makes 100 times 100, or 10,000 people, 2 steps away from you. If each of them knows 100 people, there's 100 times 100 times 100, we're up to 1,000,000 people 3 steps away from you, and then 100 million 4 steps away, and 1 trillion people 6 steps away. So what's wrong with this argument? It assumes that each of the people you know, in turn, know 100 people that are different. Most of the people you know will mostly know other people that you know. So this argument double or triple counts most people. Researchers Duncan Watts and Stephen Strogatz studied this problem for Watts' PhD dissertation at Cornell. Their results might be described as homophily plus weak links equals small world. Homophily describes the previous objection. The homophily assumption is that everybody knows everybody nearby for some definition of nearby, geographic or population density, for example. One example of weak links is that each person knows a small number of others in random, not nearby places. And that's enough to get the small world phenomenon. The random links, like my students, make large jumps to seemingly hard to reach places. But it doesn't actually take that much. If a small percentage of nodes have a single random link elsewhere, you still get the small world. Suppose the percentage is 10%, such that 1 out of every 10 people, for example, has an outside link. In a homophily group of 100, then, we have 10 people with outside links. Then each group is like a person in the first scenario. Each person/group has a small number of outside links, and you get the small world phenomenon. So the phenomenon is common. Another aspect of Milgram's experiment is that people were able to find the small number of links to the target in Boston. Watts was able to show that this too is not surprising if certain population density assumptions are met, and it appears that typical real-world friendship networks meet these assumptions. We'll finish with a couple of fun detours. The first involves my colleague Karen Saub, who has an Erdos Bacon number of 4. This is Erdos number plus Bacon number. Karen's Erdos number is 2, having published with H.A. Kierstad, who co-authored a paper with Erdos. She also has a Bacon number of 2, having appeared as an extra in Mona Lisa Smile with Julia Roberts, who was in the movie Flatliners with Kevin Bacon. Wikipedia only lists one person, Daniel Kleitman, with a smaller Erdos Bacon number. Daniel Kleitman has an Erdos number of 1 and a Bacon number of 2. Stephen Hawking and Richard Feynman both have Erdos Bacon numbers of 6. Now, to my knowledge, Karen does not have an Erdos Bacon Sabbath number, requiring you to play with the musical group Black Sabbath. Hawking has an EBS number of 8. If you want to explore Bacon numbers further, the website Oracle of Bacon is great fun. I challenge you to think of someone requiring more than 3 links. Being old, I went straight to the silent movies and Charlie Chaplin, but he's actually a 2. Along with being able to enter an actor's name and find their connections to Kevin Bacon or others, the site has compiled the average number of links to get to different actors. On average, you can get from any actor to Kevin Bacon in just 3.137 links. Sound impressive? Well, it only ranks 510th among actors in their data set as of the beginning of 2026. Number 1 is Eric Roberts at 2.919. Samuel L. Jackson is 5th at 2.952. Our man Bacon is actually just the 5th most connected Kevin, behind Dunn, Corrigan, Costner, and Pollock. Obviously, I and many others have spent a great deal of time with the Oracle of Bacon.